Hello everyone, welcome again. In this video, we'll be talking about the flag and the wind problems. Initially, we'll go through the concepts and then we'll be solving few great questions to grasp all those concepts. So let's begin. Look at this picture. What you can comment about the wind? Super. There is no wind. That's why the flags are not fluttering. Okay, let's try this again. Look at this airbag. What we can say about the wind? Correct. The airbag flutters in the direction of the wind with respect to the pole. I hope you agree with that. Let's try this again. Look at this flag. Now, what we can comment about the direction of wind? Correct. The flag flutters in the direction of the wind with respect to the pole. I hope you agree again. Okay, look at these many flags. Again, what we can comment about the wind? Brilliant. Few flags are not fluttering. It means there is no wind with respect to the pole of these flags. And for those flags which are fluttering, we can again mention the same thing, that flag flutters in the direction of the wind with respect to the pole. Okay. So here we can mark an important concept. The flag always flutters in the direction of the wind with respect to its pole. Got it? You should note down this concept, and in the entire video we'll be utilizing this concept extensively. Now let's pick up some good questions. Here is the first question. Suppose you are holding the pole of a flag and you are running forward. So, if the wind is stationary with respect to the ground, the flag will flutter in which direction? Correct? Simple answer. If you are running forward and the wind is stationary with respect to ground, the flag will flutter in the backward direction. I hope you agree with that. Can you explain the logic or the reason behind that? Great. The logic is simple. When you run with respect to the pole of the flag, where the wind will appear to move? Obviously, if you are running forward, the wind will appear to move backward with respect to the pole of the flag. So the flag will flutter in the backward direction. Simple and intuitive thing. Okay, let us try this again. Look at this question. Pause the video here and I request you to post your opinion in the comment box, and then we'll be discussing the solution. I hope you got the correct answer, which is somewhere in between the south and east. I'm explaining the logic here. Let us assume that this is the north, this is the south, here is the west, and here is the east. Okay. Now, the velocity of the car is given to us along the north direction. So, here I can mark the velocity of the car. And here we can also mark the velocity of the pole. In whatever direction the car is moving, in the same direction that pole is moving. I hope you agree with that. Next, we have to mark the velocity of the wind. According to the question, the velocity of the wind is along the east. Now, we need to determine the velocity of the wind with respect to pole. That we can write as VWP. This is according to the relative motion. And the VWP in turn can be written as velocity of wind with respect to ground plus velocity of the ground with respect to pole. I hope you remember the trick. If this is the first letter, we have to start here, and if this is the last letter, we have to reach up to that letter. So VWG plus VGP, and we maintain the sequence. Okay. Now, if we can simplify this, we'll get our answer. For that, I'm showing you the things again on the diagram. If we mark the velocity of the wind with respect to ground, which is like this, V wind with respect to ground. Okay. Usually, if something is with respect to ground, we can omit the G subscription also. Now, we need the velocity of ground with respect to pole. If the pole is moving along the north, if the car is moving along the north, the driver will see the road moving in which direction? Correct, south. You agree with that? You have observed this many times. Suppose a car is moving forward and then you look down onto the road. Where the road appears to move? The road appears to move backward. You agree with that? So if the velocity of the pole with respect to the ground is in the north direction, then the velocity of the ground with respect to the pole will be in the south direction. So I am marking that here. Velocity of the ground with respect to the pole should be somewhere here. Now, if we observe the language of the question very carefully, we do not know the magnitudes of these vectors. This vector might have this much length, this might have greater length, or vice versa. This might have smaller length, this might have greater length, they may have equal length. Depending upon their magnitudes, the resultant will lie somewhere in between the south and east direction. I hope you understood the logic. We don't know their magnitudes, so we cannot certainly say in which direction the flag will flutter, but we can have the tentative idea that flag will flutter somewhere in between the south and east. Due to the resultant of these two vectors, will get the velocity of wind with respect to the pole, and that resultant must lie somewhere in this direction in between the south and east. Got it? Simple and easy question. If you got the correct answer, let me know in the comment box, and if you got something wrong, then also let me know in the comment box. We'll talk about your doubts, we'll clarify them. Okay. When the flag will be fluttering at an angle 45, can you tell? Like this, along the southeast? Correct, when these two vectors have the same magnitude. Now you can guess. Suppose this VWG has the magnitude of 100 and this has the magnitude of 10, the VGP. Then the flag will flutter in which direction? Obviously, the resultant will be like this somewhere here. So the flag will be fluttering very close to the east direction. Let me ask you another thing. Suppose this VGP has the magnitude 100 and VWG has the magnitude, let's say, 10. Then where the flag will flutter? Obviously, this time the flag will be fluttering very close to the south direction. Got it? So depending upon the magnitude of these two vectors, we'll be able to tell the exact angle. And if we don't know the magnitude of these two vectors, we cannot tell the exact angle. I hope you understand it. Note it down, then I'll bring up the next question for you. So here is the question for your practice. I request you to pause the video here, think about your opinion, and then kindly post it in the comment box. After that, we'll check the solution. Brilliant. This time the correct answer is the southeast. Let's see the explanation here. We are taking up again the sense of direction as north here, south, and then west and east. Okay. Velocity of the car with respect to the ground is given along the north. In the same direction, we can mark the velocity of the pole with respect to ground because the pole has been mounted on the car. Okay. Now, we mark the direction of the velocity of the wind. We know that velocity of the wind with respect to the ground is given along the east. And according to the concept, the flag will flutter in the direction of the wind with respect to pole. So basically, we need to solve the VWP, means velocity of the wind with respect to pole, which is equal to VW with respect to ground plus, maintain the sequence, V ground with respect to pole. We start from the first letter and we reach at the last letter like this. Okay, the same concept will be utilizing in the entire video. So let us write up the things. Velocity of pole with respect to the ground is along the north. Then the velocity of the ground with respect to the pole will be in this direction. I hope you agree with this. Again, the repetition of the same concept. In the car, if you are sitting and the car is moving forward, you look down onto the road will appear to move backward. So the pole and the car, if they are moving along north, to the observer sitting in the car, the ground will appear to move along the south. Okay. If we simplify this relation, we need velocity of wind with respect to ground, which is marked like this. Here is the VWG. Okay. And this vector has the length 20 because the data is given as 20 km per hour. We need VGP. VGP is in this direction, and interestingly, the VGP also has the magnitude 20. This one is also 20. If two vectors have the equal magnitude, where is their resultant? Correct. The resultant is at their angle bisector, and angle between these two vectors is 90 degree. So their angle bisector will be making an angle 45 degree like this. So this is the direction of the velocity of the wind with respect to the pole. I hope you get it. Okay. So the flag will be fluttering along the southeast direction. Exactly at an angle of 45, if you mark the sense of direction like this, then this direction we call as southeast. I hope you got the same answer. So you can note it down and then we'll go further for the next question. And if you have any doubt, fire up the comment box. I'll reply. So here is the next question on the same concept. So the same request, please pause the video here, give it a try yourself and then post your opinion in the comment box. After that, we'll discuss the detailed solution. I hope you got the correct answer. The speed of the bus is 35 by 4 meter per second. Let's see the solution here. As usual, we'll assign the sense of directions. So here is the north, here is the south, this is the west and east. According to the given data of the question, the bus is moving along east. So in this direction, we should write the velocity of the bus with respect to ground. And in the same direction, we should mention the velocity of the pole with respect to the ground, because the pole has been mounted on the bus. Got it? Now, the question says the velocity of the wind with respect to the ground is 5√2 meter per second along northeast direction. What does it mean? I should mark the velocity of the wind with respect to ground like this, and this angle should be 45 degree. Length of this vector is 5√2. Later on we'll utilize that. And now we are given that velocity of the wind with respect to the pole is making an angle of 36.9 degree with north. So showing that here, velocity of the wind with respect to the pole, VWP, and this angle is given as 36.9 degree. I hope you agree with these vectors. Velocity of the bus with respect to ground is given along east, and the pole has been mounted on the bus, so velocity of the pole with respect to ground will also be along the same direction, the east. The flag flutters at an angle 36.9 degree west of north. So that has been shown like this, 36.9 degree west of north. And the velocity of the wind with respect to ground is 5√2 meter per second along the northeast direction. Northeast direction will lie exactly at the angle 45 like this. Okay. Now writing the formula, we know that velocity of the wind with respect to the pole is actually written as velocity of the wind with respect to the ground plus the velocity of the ground with respect to the pole. Do you agree with this? Let's draw the vector diagram. Velocity of the wind with respect to ground is already known to us, this vector. So this length is 5√2. Here is the velocity of the wind with respect to the ground. In this, we have to add the velocity of the ground with respect to pole. I hope you know that velocity of the ground with respect to pole, that vector will be directed like this, because the pole is moving with respect to ground in the east direction. So if some observer is sitting on the pole, for that observer, the ground will be moving along the west direction. So marking that vector also here, this I should call velocity of the ground with respect to the pole. And then we should mark the velocity of the wind with respect to the pole. This blue vector will be marked like this. Velocity of the wind with respect to the pole. Showing the known angles. Okay with the angles? Now, this length is 5√2. So, this length should be 5. Got it? And this length, the dotted one, should also be 5. This one I am talking about. Do you agree? Okay, how it comes? This angle has this opposite side, this angle has this opposite side. If two angles in a plane triangle are equal, then the opposite side lengths are also equal. So this should be 5 and this length must also be 5. Okay. Now we require this much unknown length. This data is unknown to us. I am talking about this dotted line. If we can obtain this much unknown length, we can easily find the speed of the pole with respect to ground, means the speed of the bus with respect to ground. And obtaining this unknown is very easy. Look at this triangle. Can we take up the tan of this angle? I am writing the data here. Tan of 36.9 degree should be equal to what? This unknown length, I am talking about this triangle, divided by 5. I hope you agree. How much is this data? If you remember, it is 3 by 4. So unknown length divided by 5. Here comes the unknown length is equal to 15 by 4. Done? Now this length is 5, this length is 15 by 4. So the net speed of the bus with respect to the ground will be equal to 5 plus this length was 15 by 4 meter per second. And when we simplify, we'll get 35 by 4 meter per second. I hope you understood it. Simple and easy answer. You may note it down. And if you have any doubt, I am happy to explain those doubts. Let me know in the comment box. So here lies the next question. Again, I request you to post your answer and your opinion in the comment box. I know you got the correct answer this time, which is the flag flutters at an angle tan inverse root 3 by 5 north of east. Let's see the detailed solution here. The velocity of the ship with respect to ground is given along which direction? West. I am showing that here is the velocity of the ship with respect to the ground. And in whatever direction the ship is moving, the pole mounted on the ship also moves in the same direction. So here is the velocity of the pole with respect to ground. And what if I ask you the velocity of the ground with respect to pole? It will be just anti-parallel of this vector. So velocity of the ground with respect to pole will be like this. If ship is moving in this direction, the ground will appear to move in the opposite direction with respect to the ship. Okay. Now we are given the velocity of the wind with respect to the ground, 60 degree north of east. This is the velocity of the wind with respect to the ground. Okay, we need to find the direction in which the flag will flutter, and for that what we require actually, we require the velocity of the wind with respect to the pole, because in whatever direction there is the wind with respect to the pole, the flag will flutter in that direction. This should be written as velocity of the wind with respect to ground plus velocity of the ground with respect to the pole. Same concept we are utilizing again and again. Now let us simplify the things. I am making a vector diagram according to this. Velocity of the wind with respect to ground. This vector is here and its length is 15. Let me show that here. In this, we have to add the velocity of the ground with respect to pole. That vector is oriented along east. So let us show that vector also. This vector has a length 30. How much is this angle? It's given to us. This angle is 60 degree. So marking the angle here. And according to the equation written here, will get the velocity of wind with respect to the pole by the triangle law of vector addition. So first vector, second vector and the resultant vector will be like this. This is giving us the velocity of the wind with respect to pole. We imagine this angle to be alpha. Alpha is our target, and I think it's pretty simple for you now. Why? We know this much length. If this blue length is 15, it will have a horizontal component like this. Horizontal component will be 15 cos 60, which is equal to 15 by 2. And the vertical component of this length will be 15 sin 60 degree, which will be equal to 15 root 3 by 2. Do you agree? Now I can complete this triangle. Think about it, this right triangle. Okay, I am naming this right triangle. Let's say I call it A, I call this point as B, I call this point as C. In the right triangle ACB, I am taking up tan alpha. What I should write? The tan alpha will be the BC side divided by the AC side. You agree with that? The BC side is already known to us. It is 15 root 3 by 2. And now we require the AC side. AC side is this length plus this length. So this length is 15 by 2 plus this length is 30. Okay, this was 15 by 2. I hope you agree with this. Here is the tan alpha. And when we simplify it, the alpha turns out to be tan inverse of root 3 by 5. It means the flag flutters at an angle tan inverse root 3 by 5 north of east. This is north, this is east. So tan inverse root 3 by 5 north of east. Got it? Simple and the brilliant question. I request you to note it down, and then I'll be bringing up the next question for you. So here is the next shot for you. Play it brilliant. Brilliant. You got the correct answer, as the flag flutters at an angle tan inverse 5 north of east. I'm explaining the details here. The language of the question says initially the car is stationary, so the pole is stationary and the flag flutters along the northeast. It means the velocity of the wind with respect to the ground should be along northeast. Do you agree with it? This direction indicates the northeast. Okay, now comes the second case. The car is moving along south. So this should be the velocity of the car with respect to the ground. Or this should be the velocity of the pole with respect to ground, because the pole has been mounted on the car. And the velocity of the ground with respect to the pole or car will be like this. We have done that so many times. To solve the question, we require the velocity of the wind with respect to pole in the second case. So this will be VWG plus VGP. Okay. Now we need to draw a vector diagram using the triangle law of vector addition. For that, I am taking the VWG vector here, and its length is given to us. Its length is root 2 into 10. Think about it. Do you agree with this? The number is 14.14. That number has been given intentionally. Velocity of the wind with respect to ground is given as 14.14 kilometer per hour. Actually, root 2 is 1.414. And if you multiply it with 10, you'll get the number 14.14. So this length is root 2 into 10. In velocity of the wind with respect to ground, we have to add the velocity of the ground with respect to pole. Velocity of the ground with respect to pole is also known to us. The vector lies like this. I am marking that vector here. And we know its length also. According to the question, data was 40 kilometer per hour. So this length should be 40. Clear? Resultant of these two vectors is the velocity of the wind with respect to pole. Velocity of the wind with respect to the pole will be like this, the red vector. Velocity of the wind with respect to pole. And this red vector is making some angle alpha with the east direction. Okay. If we can determine this angle alpha, we can tell the flag will be fluttering in which particular direction, because along the velocity of the wind with respect to pole, the flag flutters. Now I am naming the right triangle. This is O, this is M, and here I mark as N. So in the right triangle OMN, we wish to take up the tan alpha. The tan alpha will be NM by OM. I hope you agree with that. We require this length as well as this length. This length is actually 10. This length is also actually 10. I hope you understand it directly, because this length is root 2 into 10 and it's a right triangle. This angle is 45. We know it from here. Okay, VWG was making an angle 45 with the east. So this angle is also 45. This is also 45 here. If this is 45, this is 45, this angle is 90 degree. Anyone can tell this length will be 10 and this length will also be 10. Okay. So I think getting the tan alpha is now super easy for us. This total length NM is visible to us 50. This length OM is 10. So tan alpha is equal to 5. So alpha is equal to tan inverse 5. It means the flag flutters in the second case when the car is moving at an angle tan inverse 5 north of east. Got it? Simple and easy solution. I hope you have done the things in the same way. If you enjoyed this, I'll bring up the next level of the question on the next screen. You may note it down. So here is the family pack, the last question of this video. The river is flowing, the boat is moving in the river, and the wind is also blowing. We have to find the direction in which the flag will flutter. I hope you'll enjoy it. So keep enjoying. I'll see you again after few seconds. I hope you got the correct answer, which is the flag flutters at an angle tan inverse 5 by 8 east of south. As usual, let's draw the sense of directions first. This is north, here is the south, here is the west, and here is the east. Okay. According to the given language, velocity of the river with respect to ground is in this direction along east. So here is the velocity of the river with respect to ground. The language says the boat is steered. The boat is steered on the water. You understand it? So the given velocity is actually the velocity of the boat with respect to the river. You understand the meaning of the steering of the boat? Boat is steered in the water. So the given velocity of the boat is the velocity of the boat with respect to the river. This is 37 degree north of west. And here I am showing the velocity of the boat with respect to the river. Got it? And in the same direction, we can show the velocity of the pole with respect to the river, because the pole has been mounted on the boat. And if we require the velocity of the river with respect to the pole or with respect to the boat, that will be shown in this direction. This angle must be 37 degree. Got it? Next data. We know the velocity of the wind. This direction is southwest. Here is the velocity of the wind with respect to ground. Got it? Now we know the concept. We require to find the direction in which the flag will flutter, and for that we require the velocity of the wind with respect to the pole of the flag. The flag will flutter in the direction of the velocity of the wind with respect to the pole. So let us use the relative motion. We'll write velocity of the wind, the first letter here, with respect to ground, plus velocity of the ground with respect to river, plus the velocity of the river with respect to pole. Actually, we start from this letter and we reach here. So started here, we reached here, and then we follow sequence G, G, R, R. Okay. We have to draw a vector diagram. Suppose we consider this as the origin. So here I mark up the origin, and first of all, I'll show the velocity of the wind with respect to ground like this. We know this length is given as 10 root 2. If this length is 10 root 2, we can mark few lengths very easily. This length, vertical one, is also 10, as well as this horizontal length is also 10. I hope you agree with the things. Now in VWG, we have to add VGR, velocity of the ground with respect to river. If VRG is in this direction, then can we say that VGR will be in this direction? So marking that vector here, this is VGR. And what is its length given to us? According to the data given in the question, this length is 5. I hope you agree with this. Now we have to add up VRP. VRP is making an angle 37 with the east as shown. So I am showing that VRP here. And it was making here an angle of 37 degree. This length was 50. If you have read the language carefully. So we can mark few more lengths. I wish to complete a triangle here like this. This length should be equal to 30. and this length should be equal to 40. I hope you understand this. 50 cos 37 will give this horizontal length, which will come out to be 40, and 50 sin 37 will give up this length, which is equal to 30. We already know this length. This comes out to be 10, and the resultant of these three vectors is equal to velocity of wind with respect to pole. First vector, second vector, third vector, their resultant will be marked like this. I hope you get it. This red is giving us the velocity of the wind with respect to the pole of the flag. So basically we require this angle as alpha. I hope you understand. I am completing the triangle here. You get this triangle? Let me name it. This is O, this is M, this is N. In triangle OMN, we need the value of 10 alpha. So how much is 10 alpha? 10 alpha is equal to Mn by OM. Okay, how much is Mn? Out of 40, this length is 15. So the remaining length Mn should be 25. Clear to you? Mn is 25. How much is OM? It is directly visible. This is 40. So the 10 alpha comes out to be 5 by 8, or alpha comes out to be 10 inverse of 5 by 8. It means the flag flutters in this direction. Velocity of wind with respect to the pole is making an angle alpha, 10 inverse 5 by 8, east of south. I hope you got the same answer. And if you liked this video, share it with your friends. And if you have any doubt, let me know in the comment box. Stay awesome. See you again.